This lesson, we are going to introduce derivatives of sines and cosines, and then we're going to do an example related to that. So our example for this is we are going to be doing the derivative of sine. Derivative of sine is equal to cosine. And the derivative of cosine is going to be equal to negative sine. So the derivative of any co is going to be a negative. So that is what we're going to use to help figure out these couple questions or this question, but a couple things related to it. So first thing is we have our original function here. We're going to try to find the slope equation and then find the slope at a particular point. Then we're going to do the second derivative and then find the second derivative's value at that point. So first part of this is let's find our slope equation. Let's do our derivative. Now we have a product rule that's happening here. So we're going to be doing the derivative of the first times the second. So we'll just kind of go through the whole process here. So if we're doing this, we're going to clump the 9 onto the sine. So we're going to be doing the derivative of the first times the second. So we're going to have 9 cosine x times cosine x. So there's the derivative of the first times the second. And then plus the first times the derivative of the second. And the derivative of cosine is negative sine. All right, so if I put this together, we're looking at our derivative equation being 9 cosine squared minus 9 sine squared. All right, so we could factor a 9 out, but we're not really going to get that much better. The cosine squared minus sine squared is not really anything special. So we're just going to then go to the next phase of this, and we're going to be plugging in what's the slope at negative pi over 3. All right, so we're going to be doing, if we do the math here, we're doing 9 times cosine of negative pi over 3, and that piece is going to be squared, minus 9 times sine of negative pi over 3 squared. All right, so I need to figure out those values. We can square them. We can multiply them by 9. We can kind of get our final answer. So unit circle, either you're looking at a unit circle. I do this a little bit different. I just refer to pieces of my 30, 60, 90. So I know that the relationships on a 30, 60, 90 look like that. And then what I got to figure out is my A Smart Trig class to figure out whether these values are positives or negatives. So pi over 3 refers to a 60-degree reference angle. And so when I do sine of 60, I'm going to be doing root 3 over 2. And when I do cosine of 60, I'm going to be doing 1/2. And then negative pi over 3 is going to be down in this quadrant. So cosine's the only positive, so sine will be negative. Okay, I just need to tack those pieces onto it. So math on this is cosine of this. So cosine of fourth quadrant is going to be 1/2, and it's going to be positive. So that's 1/2. We're going to square that. Minus 9 times sine in that quadrant. Sine is root 3 over 2, but it'll be negative. So negative root 3 over 2, but we're going to be squaring it. So we're looking at 9 times a fourth minus 9 times positive's going to go, or the negative's going to go away because we're squaring it. We're squaring the root 3, so that's a 3 over 4. So we're looking at, let's not mess with the common denominators or anything. So we're looking at 9/4 minus 27/4. So we're getting a final answer of negative 18/4, which simplifies out to negative 9/2. So there's our slope at that one. And then we're going to do the second part of this is finding the second derivative and then plugging in the exact same value. So we're going to be probably using some of these exact same values. We'll have to see what this math turns out to be. But this is our slope equation that we're taking the second derivative of. So before I do that, I'm going to rewrite this to a little bit more of a derivative friendly. So I'm going to write this as 9. Maybe I'll factor out the 9. Let's just leave it. So 9 cosine x squared minus 9 sine x squared. So that's really what I have going on to kind of make it more of a derivative friendly kind of a look to it. So when I do my second derivative, I have a chain rule that's going to be applied to this. So that 2 is going to multiply the 9 to an 18. And then we'll have cosine x, right? And that becomes a power of 1. So I'll erase that on the next one. But power comes down, so we do the derivative of the outside, don't change the inside, and then times the derivative of the inside, which is going to be negative sine. Right, so there's that first piece, and then minus, again, same 18, derivative of the outside. Let's drop our power, and then times the derivative of the inside. All right, so if I clean this up, we're looking at negative 18 cosine sine. And then minus 18 cosine sine again. Right, and then actually that can combine, might as well. Let's have less terms. So it's a negative 36 cosine sine. So there's our second derivative. Now let's find what the value is at negative pi over 3 again. So negative 36 cosine negative pi over 3 times sine negative pi over 3. And we already know that cosine of negative pi over 3 was over here, so we have a 1/2 on that. So that's going to be negative 36. Negative 36 times 1/2. And then sine of negative pi over 3 was negative root 3 over 2. So if we mix all that together, I can do a little bit of simplifying. I can take a 2 out of the 36, making that an 18, and then I can take another 2 out of that 36 and make it a 9. So we have no more denominator. We have a negative 9 times a negative root 3, so that'll turn out to be a positive 9 root 3. All right, so there was our second derivative. We were doing our first derivative, plugging in a value, doing our second derivative, plugging in a value. Those are our slopes.